Tonight, we're looking into posts being spread on social media. They claim the James Webb Space Telescope spotted a large object about 10 light years away moving toward Earth.
Mysterious objects are hurtling toward Earth, putting the United States government on high alert. The skies are teeming with activity as scientists race against time to understand the threat posed by these cosmic intruders. This isn't some distant hypothesis. The danger is real, and every moment matters. Join us as we delve into the chilling details, the ongoing efforts, and the catastrophic possibilities that could alter life as we know it. The journey into cosmic threats and survival begins with Bennu, a name that should already grab your attention. This 500-meter-wide asteroid has been a subject of intense scrutiny for years. It's not set to hit us anytime soon, but if it does in the 22nd century, it could be catastrophic. Scientists aren't just sitting around worrying, though. They sent out a mission, Osiris-REx, to scoop up some of Bennu's surface dirt and bring it back to Earth. Why? To figure out what makes this asteroid tick. Knowing its makeup and behavior can help us prepare for worst-case scenarios, like building technology to shove it off course or brace for impact. Even though the chances are low, the stakes are sky-high. Bennu hides a secret that could upend everything we know about near-Earth objects. Bennu isn't the only cosmic concern keeping people on edge. Another asteroid, Apophis, caused plenty of sleepless nights in the past. The good news? It won't be crashing into Earth anytime soon. The bad news? It's set to pass uncomfortably close in 2029. Scientists plan to seize this opportunity to study it up close, like observing a wild animal from a safe distance while taking detailed notes. This effort is part of a larger mission to monitor and understand near-Earth objects, NEOs. Better to be prepared than caught off guard, right? And while asteroids grab the headlines, let's not forget the sun, a life-giving giant fireball that also happens to be a ticking time bomb. Solar flares, basically explosions on the sun's surface, can cause geomagnetic storms here on Earth. These storms can mess with everything. Satellites, GPS, power grids, you name it. Back in 1989, one such storm knocked out power across Quebec, leaving millions in the dark. Imagine that happening today, when we're even more dependent on technology. It's no wonder that forecasting space weather has become a full-time gig. The goal is to spot these solar temper tantrums before they hit and minimize the damage. And then there are rogue planets, enormous solitary wanderers ejected from their star systems. These cosmic drifters glide through the void without a destination. While the odds of one colliding with Earth are incredibly remote, their mere existence is enough to keep astronomers restless. If one ventured too close, it could disrupt the fragile harmony of our solar system. Planets might be nudged from their orbits, leading to all sorts of turmoil. Rogue planets are enigmatic and leave us pondering what other mysteries the universe holds. Could they harbor life? Perhaps, but don't count on them being welcoming neighbors. Rogue planets aren't just fascinating anomalies, they're reminders of how chaotic the cosmos really is. Imagine a world without a star, left to wander in eternal darkness. The temperatures on such planets are extreme, often plummeting to hundreds of degrees below freezing. Yet some scientists theorize that these planets might have subsurface oceans warmed by their own internal heat. Could life survive in such an environment? It's a question that keeps researchers awake at night. Even though the odds of a rogue planet crossing paths with Earth are tiny, the consequences of such an event would be catastrophic. Black holes, nature's ultimate cosmic predators. While they're not actively pursuing Earth, their immense gravity is so powerful that even light cannot escape their grasp. If one drifted too close, it could wreak havoc on the solar system, flinging planets and asteroids around like playthings. Fortunately, the nearest supermassive black hole is both distant and well-behaved. However, the universe is scattered with rogue black holes, and one passing through our region of space could spell disaster. And let's not overlook those black holes lurking silently in the background, distant but still shaping the cosmos around them. Supermassive black holes are found at the centers of galaxies, including our own Milky Way. The one at the heart of our galaxy, Sagittarius A*, is massive, yet relatively calm. But what if it weren't? A more active black hole could send out jets of radiation that might affect life on Earth. The idea of a wandering black hole moving through our solar system might sound like pure science fiction, but the universe has a way of surprising us. It's better to understand these phenomena than to ignore them. Amid all this activity, it's natural to feel as though Earth is simply a target waiting to be struck. However, the truth is far more nuanced. Scientists and engineers are tirelessly working to understand these potential threats and devise strategies to protect our planet. From tracking asteroids and forecasting solar storms to investigating rogue planets, every piece of information plays a crucial role. For instance, there's increasing focus on developing planetary defense systems, technologies designed to deflect or even dismantle an asteroid before it reaches Earth. Missions like NASA's Double Asteroid Redirection Test, DART, are leading the charge in advancing these groundbreaking solutions. The DART mission successfully altered the orbit of a small asteroid, proving that we can influence the movement of celestial objects. This is a crucial step in preparing for any future threats. Then, there's the challenge of predicting and mitigating the effects of solar storms. Scientists use satellites to monitor the sun's activity and provide early warnings of geomagnetic storms. Governments and power companies are also investing in technologies to protect critical infrastructure, such as power grids, from the effects of these storms. While we can't stop solar flares from happening, we can reduce their impact on our daily lives. Advancements are also being made in the study of rogue planets. Astronomers are utilizing powerful telescopes to detect these free-floating worlds and uncover their unique characteristics. By exploring how rogue planets form and interact with their surroundings, scientists are refining planetary system models and expanding our understanding of the universe. Who knows? We might even stumble upon a rogue planet with conditions that could support life, opening doors to new avenues of exploration. Similarly, black holes are under closer scrutiny than ever before. In 2019, the Event Horizon Telescope, a global network of telescopes, achieved a groundbreaking milestone by capturing the first-ever image of a black hole. This groundbreaking achievement has opened up new avenues for understanding these enigmatic objects. Scientists are now working to create more detailed images and gather data on how black holes interact with their surroundings. These efforts could help us better predict the behavior of black holes and their potential impact on Earth. Next, we look at a space rock getting uncomfortably close to Earth. Cosmic fire drills. Let's talk about Apophis again for a moment. Discovered in the early 2000s, this chunk of rock is over 12,200 feet wide, roughly the size of 3 football fields placed end to end. If this bad boy were to collide with Earth, it would be like an uninvited city-destroying fireworks show. Fortunately, scientists have assured us that Apophis won't crash into Earth during its close approach on April 13, 2029. However, it will come uncomfortably close, closer than some of our satellites. Picture looking up and spotting a glowing dot streaking across the sky. That's Apophis, a once-in-a-lifetime spectacle, hopefully without any disastrous consequences. But here's the twist. While we're safe in 2029, Earth's gravity might alter Apophis's orbit just enough to make its next flyby in 2036 a potential concern. This possibility has scientists on high alert, running simulations and prepping plans. Because let's face it, you don't want to gamble with something that could turn your favorite city into a crater. NASA has already started conducting asteroid preparedness drills. Think of these as cosmic fire drills, but with a lot more math and way higher stakes. One recent simulation threw a curveball. An imaginary asteroid, invisible until it was practically on Earth's doorstep, with only 6 months of warning. The result? A grim realization that we're not exactly ready to handle such a scenario. Current technologies, such as using a spacecraft to collide with an asteroid to alter its trajectory, require years of preparation. And let's not even touch on the complexities of international cooperation for such a task. The issue isn't limited to Apophis alone. There are countless other asteroids zipping through space, many too small to be detected by our telescopes until they're nearly upon us. Take the 2013 Chelyabinsk meteor, for example. At just 60 feet wide, it exploded over Russia with the force of several nuclear bombs. Windows were shattered, thousands were injured, and it served as a stark reminder of how vulnerable we are to unexpected cosmic events. Scientists are trying to improve our odds. NASA's Scout system, for example, recently tracked a tiny asteroid that burned up harmlessly over Germany. That success shows progress in monitoring these space rocks, but it's still a far cry from being ready for the big ones. International cooperation is also a must. An asteroid impact wouldn't just be one country's problem. It'd be a global disaster. But getting countries to agree on how to handle it is another story. The recent drills reveal gaps in communication, planning, and available technology. Let's take a moment to revisit the collision that forever altered life on Earth. Are we prepared for another impact? 66 million years ago, a colossal object crashed into what is now Mexico's Yucatan Peninsula. The result? A catastrophic extinction event that wiped out 75% of life on Earth, including the dinosaurs. After dominating the planet for more than 100 million years, their reign came to an abrupt end. It's a haunting question. Could a similar disaster strike again? Asteroids crashing into Earth isn't science fiction, it's a fact. Impact craters scattered across the globe are evidence of these cosmic collisions. Experts like Dr. David Kring, a planetary geologist, and Dr. Mark Boslow, a physicist, study these impacts to understand their scale and implications. For example, the Chicxulub crater, a massive depression buried beneath Mexico's Gulf Coast, is thought to be about 110 miles wide. It was created by an asteroid roughly 6 miles across. That's like a rock the size of a city slamming into Earth at mind-boggling speeds. What occurs when an asteroid strikes Earth? Initially, it plows through the atmosphere, heating up and disintegrating as it impacts. Take the Chicxulub asteroid, for example. It displaced huge volumes of air, generating a plasma that emitted heat and light. The explosion was so powerful it matched the extreme temperatures of the sun's surface. Picture rocks and debris being hurled 60 miles into the sky, 10 times the height of Mount Everest, before cascading back down. Fires erupted worldwide, while the atmosphere became thick with ash and dust. And then there's the water. An impact near the ocean sends towering tsunamis crashing across the planet. At Chicxulub, waves at least 300 feet high surged across the Gulf of Mexico, inundating what is now Texas and pushing inland. A wave of that scale would make skyscrapers look puny. Cities would be wiped off the map. The aftermath of an asteroid impact is nothing short of apocalyptic. The Chicxulub event ejected an estimated 10 trillion tons of debris into the atmosphere, blotting out the sun. Without sunlight, plants die, disrupting the food chain from the bottom up. Temperatures plummet, triggering an ice age. Earthquakes ripple through the crust, and the ground shakes. The Earth trembles violently as structures collapse, roads vanish, and our way of life is shattered. But what if this scenario unfolded today? An asteroid just a few miles wide, tiny compared to Chicxulub, could unleash destruction on an unimaginable scale. A direct impact near a major city would obliterate everything within a vast radius, with heat instantly vaporizing life. Even smaller impacts, such as an airburst, could reduce a city to ashes or cause catastrophic damage. The most terrifying part? Earth is constantly bombarded by space rocks. Most are tiny dust particles that burn up harmlessly in the atmosphere, but larger objects, those a few meters wide or more, can reach the surface. Scientists estimate Earth has been struck over 60 times by objects 3 miles wide or larger in the last 600 million years. While efforts are underway to monitor potential threats, organizations like NASA face daunting challenges. Some asteroids are nearly invisible, their dark surfaces blending with the void of space. Current deflection plans, like ramming a spacecraft into an asteroid to change its trajectory, are still theoretical and require advanced warning. Without protection, humanity would struggle to defend against a sudden impact from space. The Chicxulub impact serves as a stark reminder of Earth's vulnerability. Sulfur-rich rocks in the area, combined with the asteroid's own sulfur content, created a toxic atmosphere. The resulting gases lingered for decades, disrupting the climate and exacerbating global warming. If a similar event were to occur today, the greenhouse effects could persist for centuries, further destabilizing an already fragile ecosystem. Even smaller asteroids, just a few hundred feet in size, pose a significant threat. as they are much more common and could destroy cities or cause widespread damage. With over 800,000 asteroids identified in our solar system, the odds of a significant collision are far from zero. The lesson is clear: Earth is vulnerable. Advanced technologies and space programs provide hope, but humanity must prepare for the unpredictable. The vast crater at Chicxulub stands as a reminder of our planet's violent history and our responsibility to protect its future. Better detection systems, global cooperation, and innovative solutions are crucial, as the next big impact might not be 66 million years away. To grasp the devastation an asteroid impact could bring today, consider the implications beyond the immediate blast zone. The impact would release kinetic energy on a scale of tens of millions of megatons, far surpassing the power of the largest nuclear bombs ever detonated, including the Tsar Bomba. Thermal radiation could ignite fires across vast distances, setting ablaze forests, fields, and cities. The shockwave would demolish buildings, uproot trees, and reshape the landscape permanently. Beyond the immediate destruction, the secondary consequences would be catastrophic. Dust and ash thrown into the atmosphere could trigger a nuclear winter, crippling global agriculture, causing widespread famine, and leading to the collapse of society. Wildlife and marine ecosystems would face severe disruption as food chains collapse. Tsunamis triggered by an oceanic impact would ravage coastlines, with towering waves sweeping away cities and displacing millions. The psychological impact on survivors, along with the immense logistical challenges in delivering aid and rebuilding, would overwhelm global resources. Long-term climatic consequences, such as diminished sunlight and the release of toxic gases like sulfur dioxide, could drastically alter Earth's atmosphere, making it less conducive to life. Additionally, technological infrastructure would be at risk, with debris damaging satellites and electromagnetic pulses causing widespread power grid failures. The increasing reliance of modern civilization on interconnected systems presents a potential vulnerability. As such, planetary defense has never been more crucial. Scientists and engineers are investigating strategies to prevent or reduce the effects of asteroid impacts, such as the gravity tractor method, where a spacecraft uses its gravitational pull to change an asteroid's path, or employing solar sails and rocket engines to redirect it. These methods require meticulous calculations and extensive preparation, highlighting the necessity of early detection. Public awareness and global collaboration are key. Governments, scientific bodies, and private sectors must invest in research, develop new technologies, and educate the public on potential risks and how to prepare. Funding asteroid detection systems and response strategies is not merely a scientific pursuit, it's a vital step in safeguarding Earth's future.